DevOps promotes only automation. Now, application is deployed in the Docker container. However, the story doesn't end here. We have seen what is DevOps in the previous video. Let me give you guys a quick recap. So, DevOps is a concept and a methodology which unites the software development and IT operations team to achieve faster, smoother, and more efficient software delivery by automating the repetitive tasks. But ever wonder how DevOps engineer accomplish this complicated process in no time? DevOps engineer makes the use of tons of tools to automate the repetitive tasks. These tasks are building, testing, deployment, and more. In building tasks, developer compile the source code which is written in human readable language, for example C, C++, Java, into machine code that is ones and zeros because computer only understands zeros and ones language. Then compile code is packaged into an executable format like .jar file or .exe file. In testing phase, code will be tested based on various test cases to ensure each code's function is working fine and meet the requirement. When code passes all the tests, then code is ready for the deployment on the servers and it will be made available for the end users to use. However, the story doesn't end here. The ops engineer also ensures that application is always up and running by monitoring the application's resources like CPU, memory, storage. Before DevOps, developer would complete their code and manually transfer it to the operations team using emails or physical media like pen drives. But what if local machine or hard disk or pen drive gets crashed? Also, multiple developers are working on the same project, but some developers are working on the one module of the project, whereas some developers are working on the another module. When it's time to merging their code changes, they often faced conflicts. It was very difficult to track changes and merging their code changes. But DevOps engineer makes the use of version control system, that is Git and GitHub, to get rid of these issues. Using GitHub, sharing code with other team members becomes way easier. Using Git, developer can push their code to a GitHub repository. Git helps developer to keep track of changes in their code, which means you always go back to the previous version if something goes wrong. Now, with the help of Git, developer can push the code to a GitHub repository, so ops engineer can clone the code, execute the code on his local machine. But code will run locally in closed environments, only available to him and not the outer world. To make code accessible worldwide, we need to deploy code on the servers. It is very costly to purchase physical servers and install them in a data center. Not only this, but securing the servers, power consumption, cooling, and physical space requirements increase more cost. Instead of using physical servers, DevOps engineer deploy the application on cloud like AWS Cloud. So AWS Cloud provides service called EC2 instance, which is a virtual server. DevOps engineer can deploy and manage the application on EC2 virtual server. Yes, to create AWS EC2 instance, we need to go on AWS Management Console and select configurations like what instance type we need, which operating system we want, which key pair we will use, what security groups we want. We set inbound and outbound traffic rules manually. Am I right? No, if you think so, you guys are wrong. DevOps promotes only automation, so DevOps engineer will create EC2 instance automatically using infrastructure as a code tool like Terraform, CloudFormation, Ansible, and more. In our case, we are using Terraform as a ISE tool to create a EC2 instance automatically. You just have to write a configuration file with .tf extension in HCL language in which you will define number of instances you want, operating system you want, and other configurations. As you can see here, I have not created any instance manually and not even any instance running here. Okay, so I have a Terraform configuration file with me to create a AWS infrastructure. In this file, I have defined all the necessary configurations which I need. I defined required providers as AWS since I want AWS as my cloud provider. But you can define any cloud provider such as GCP, Microsoft Azure, and whatever you wish. Then I've defined region as US East 1 and I started defining what resources I need. After executing my Terraform commands, you will see EC2 instance will be automatically created in AWS Management Console. I executed Terraform init and Terraform plan commands before, as I am not creating this infrastructure for the first time. But whenever you guys write your Terraform file for the first time, you must execute Terraform init and Terraform plan commands. I created this Terraform file long ago. I am just showing you for the better understanding purpose. Terraform init command is essential to initialize the configuration file as well as download and install the cloud provider plugins. Without Terraform init command, you will be not able to create your cloud infrastructure. I was typing my Terraform apply command, which is Terraform apply -auto -approve. And as you can see, after executing Terraform apply command, it is automatically started creating AWS infrastructure. And our AWS infrastructure is created automatically. Let's check it is created in our AWS console or not. Let's just refresh. You see our instance is created in just 2 minutes. It's as simple as making 2-minute noodles, no? Consider one scenario where developers code working fine in developers environment, but it's not working fine on production environment or testing environment because they might have missing dependencies or mismatch configuration, which leads it's not working on my machine problem. So engineers used to configure servers and install dependencies manually, which is error prone and take a lot of time. And here's the blame game starts. The tester blames developer, developer blames the tester, which leads delay in software release. To resolve this issue, DevOps engineer adapts the containerization tool, and most popular tool is Docker. DevOps engineer writes a Docker file which contains the instructions to build a Docker image. From Docker file, Docker image is created. Docker image is nothing but the package in which all the things already present which are required to run an application, including code, dependencies, runtime, and whatnot. After executing Docker run command, our container is created from the image. DevOps engineer packed an application and its dependencies into a Docker container. Now application is deployed in the Docker container, eliminating its working on my machine problem, ensuring that it runs the same way on any system with Docker installed. Okay, now let's consider you have to deploy the code on development server, testing server, and ops server as well. So what you will do in this scenario, you first go and install Git, GitHub, Terraform on development server and then repeat the same thing on testing server manually. No, right? Remember only automation principle of DevOps. To manage configuration and perform automation tasks on multiple machines, DevOps engineer use configuration management or automation tool like Ansible, Chef, or Puppet. To perform automation tasks on development server and testing server, we are using Ansible. Ansible works on master-slave concept. From one master server, we can easily manage and install the softwares in number of target servers. Ansible uses inventory file. Inventory file is nothing but the text file which contains target machine's IP address, host name, and whatever it needs to log into that target machine. Using inventory, master server with Ansible installed makes the connection with the target machines and automatically installs the Git, GitHub, Terraform, Ansible, and Docker in development server as well as the testing server from one deployment server. For that, we have to write Ansible playbook. Ansible playbook is a YAML file that defines automation tasks that we want to perform. Like we are instructing Ansible that, hey, listen, I am writing here list of softwares that I need. Please download, installs, and starts them in development server and testing server. And Ansible is so smart, intelligent tool, it will do things automatically, that too without even touching the servers. That's it with the part 1. In the next part, we will dive into more important DevOps tools. Few days back during an interview, I was asked about a specific tool which I will share with you guys in the next part. So stay tuned and thank you so much for watching. Bye.